Hey folks, how's it going? This is Mr. Murray coming to you with a little video on quadratics in vertex form. Okay, so today in class what we discussed is we talked about how we can have another form for a parabola that's defined in terms of the vertex, okay? And we saw the reemergence of h and k in this form, okay? So vertex form looks like this, right? So we have f of x, or whatever letter you decide to use to represent your function, okay, is equal to a times x minus h in parentheses squared plus k. Okay. In class, we talked about some of the features they have in common, and I encourage you to take a look at my other video about graphing quadratics, where I really talk about some of the features, such as a. We saw today that a plays the exact same role in vertex form as it does in standard form, right? We know standard form is ax squared plus bx plus c, and we know that this a and this a play the exact same role in their respective forms of the function. So that's important, right? Okay. The other thing we noticed was that h and k was always the coordinates of the vertex. For example, as you see here, with a positive a making a smiley face or upwards facing parabola with a minimum vertex, and a less than 0 making a sad face parabola, so to speak, with the vertex and maximum. Remember, we talked about positive a, happy, smile, right? Negative a, sad, right? Negative. Okay, so those are some of the features we talked about, right? And so again, a is important, right, in helping us understand the form, but also in the fact that these are, playing the same role, right? And remember that we always leave this as x. This always just keep this as x because you always need something to plug into. Now, how do we know this is the vertex, though? That's a good question. So essentially, what's going on here is that we have some quantity, and this quantity is being added to a number k, okay? Notice that k is a constant, right? No matter what x is, it doesn't matter with regard to k, right? It's always going to be the last step of adding k. If x is 1, you're going to do this, but you're still going to add k. And that's never going to change no matter what, okay? So essentially, if this value right here was 0, right? That's the smallest number, or sometimes the largest number that you could add to k. So think about if a was positive. For example, if we had x minus 2 squared plus 3. So it's some quantity that's being added to 3, all right? Now, if you think about it, well, this quantity, what's the smallest thing that you're going to be able to add to 3? In this case, because of the squared, we know that the only kinds of numbers you get when you square something are positives and 0. And if we think about it, the smallest thing that we can add to 3 is 0. So in other words, whatever makes this thing in the parentheses equal to 0 represents the largest or the smallest value. Now, if this is a negative in front of it, such as negative x minus 2 squared plus 3, notice that these are being subtracted from 3 because these are negative. So, for example, if I plugged in 3, getting 3 minus 2 is 1, 1 squared is 1, this becomes a negative 1. I'm subtracting 1 from 3. I get 2, right? Then, if I made it, for example, 6, or actually 4, 4 minus 2 is 2. 2 squared is 4, so that's negative 4 plus 3. So now I'm at negative 1, right? Things are being subtracted away from 3, right? So 0 represents the smallest thing being taken away, and taking away the smallest amount represents the biggest possible value that you can attain, okay? So the goal that we learned is that just as with absolute value, Okay, just as with point slope form, our goal is you want to make this equal to 0. Okay, because that's going to tell you where your vertex is. And once you get your vertex, everything else follows. Consider the fact that the symmetry is still present. So you have the buy one, get one, okay, that we talked about. The 1, 3, 5 pattern that we saw, the 2, 6, 10 pattern that we saw, etc., depending on A. That's going to still apply, but it's just a little bit different to graph it. So the benefits of this is that you can get the vertex right away, but some of the downsides we're going to see is that you're going to start in a different place because you're given, some information here is not as easy to find. Okay, so I hope that you found this to be like a good introductory kind of explanation to some of the stuff we've been doing. Hopefully I really got everything that I needed to get there. If you need to rewind and anything to kind of review anything I said again, feel free. But then in a moment, I'm going to move on to a problem that I'll show you. Okay, so what I have here is, so again, as with many of my videos, there's going to be some problems that I'm going to do. There's going to be some problems that I'm going to kind of do, but elicit maybe your feedback during. That's kind of like a we do. And then there's going to be problems for you to try on your own. As usual, there should be timestamps in the description. So please feel free to skip through problems and do the ones that you find that will be most helpful to help you understand what you need to do. Okay, I understand that sometimes the movies go long, so that's totally, like, I totally will not hold it against you. I would rather you watch 10 minutes than watch none. Okay, so, well, hopefully you watch the whole thing, right? Okay, so for me to do, so usually I would tell you, as in the other videos, start with 0. Today in class we talked about why that's not the right thing to do. So we talked about how, well, yeah, you could plug in 0, but that's not going to be as easy to plug in, right? A student went, oh, well, isn't it 0, 3? And another student remarked that, no, not really, right? Because now when you plug in 0, first you're adding 5, you're squaring it, and you're subtracting 3. So in this case, it's not that difficult to do, but in general, but here's the issue, right? This is not going to fit on this graph. So 0 is not as useful anymore, but it doesn't mean it's unimportant. I do care about the y-intercepts, but that's just not where we're going to start. Instead, we're going to take a look inside here. And look, I'm not about making you learn rules, right? What I asked was, what's the easiest number to plug in? If we think about making this as easy as possible to figure out the y value, what would you choose? And a student noted that, what if I choose -5? Well, if I choose -5, then what's going to happen is I'm going to get -5 plus 5, and that's 0. And when I square 0, I get 0. And when I subtract 3, I get -3 or -3. So at this point, right, 0, remember, whatever comes out of here, because it's being squared, I know it's always going to be either 0 or a positive number, right? And because this number is essentially being added to -3, what I know is that this represents the smallest possible thing that can be added to 3, right? 0 is the smallest thing you can add to any, if you're looking at positives and 0, right? 0 is the smallest number that you can add to something, right? Where if you're looking to minimize the sum, right? So in any case, I want this to be -5 because this will give me the smallest possible number to add to -3, making it the minimum. And remember, because our a value is -1, or rather +1, I know it's positive, so this thing should point up, right? So now I have -5 and -3. So I'm going to go ahead and plot that. 1, 2, 3. Sorry if any of those explanations might have been confusing there. I'm just trying to get an understanding. Why am I plugging in? Why am I making this 0, right? All right. So another student suggested, like, look, here's the thing. Now you have the vertex. Why not try to plug in some x's right around the vertex, right? So if I'm right around the vertex, what am I thinking? So I've got -5, 3. Now I have the freedom, the luxury of being able to move some of these around, right? So what about maybe -4 and -6, each of which are 1 away from 5, right? And just as with before, as we understood those patterns, right? So that's why I really emphasize these patterns in class, because they come up over and over again, right? So -4 and -6, we know they're the same distance away from the x of the vertex, right? So because this is a quadratic, that tells us they're going to have the same y value. So I can either plug in -4 or -6, and know the y values are going to be the same. I'm going to choose to plug in -4 because when I add 5 to -4, what I get is I get 1, I square the 1, and I subtract 3. That's what the formula tells me to do. And that gives me 1 minus 3, or -2. Because these are the same distance away from -5, you're also going to get -2. Because look, if I plug in -6, what's going to happen? All I'm going to get is this, -1 squared minus 3. But look, -1 squared is 1. So look, the problems are going to turn out exactly the same. And that has to do with, again, the symmetry. The fact that this is what I would call an even function. Okay? In this case, if it was just this, right? To the extent that the squaring is an even function. I want to be clear. The action of simply squaring is an even function. If you plug in the negative number and you plug in the positive of that same number, right? A number in its opposite, you'll get the same answer, right? -1 squared is 1 squared. -2 squared is the same thing as 2 squared. -3 squared is the same thing as 3 squared, right? 9, 9, 4, 4, etc. That is partially what is causing the symmetry, right? Because what's the only number when you square it, there's no match? It's 0, right? 0 squared is 0. No other number when you square it is 0. So the idea that we could make this 0 also tells us that we're going to get an output that's unique. It's the only one of them we're going to get, because only one possible thing can be squared to get 0. Okay, and that's another reason why we're shooting to get this 0. Okay, so now I'm going to plot these points. Now, someone commented that there is a pattern, like a 1, 3, 5 pattern. At this point, if you know how to find the patterns, you can feel free to do that. The pattern would indicate that -3, 1 would be my next y value. So I'm going to plug in my next coordinate point. So I'm going to plug in -3 and -1. I'm just going to put them down here. These are both 2 away from -5. Right, not -1, -7, I'm sorry. -3, -7 are the same distance away from -5. So therefore, they're going to have the same y values. -3 on one side, -7 on the other. Okay? All right. So knowing this, let's see what we can do. So I'm going to plug in -3. -3 plus 5 is 2. 2 squared is 4, right? Is 4. 4 minus 3 is 1. Exactly as we predicted. And we know -7 has to be the same. And if you plug in -7, you get, notice, this is what you get. But look, these are going to both lead to the same number when you square them. And since all you're doing is subtracting 3, right, this doesn't depend on x. Well, once you get the same number when you square it, the rest of it is just going to be the same idea, right? Not, that's going to ensure that the corresponding outputs are the same. Okay, so we have the vertex and 4 other points. All right, so I hope this made sense to you. I really encourage you to go back and explore, and again, go through how I did this and consider, like, why things were able to be done the way they were, how I got the vertex, which is the red point in the table, okay, how I was able to use the symmetry, right? Remember that nice axis of symmetry. And the axis of symmetry is x equals -5, right? That's notice how it goes through -5 on the x-axis, more or less, okay? and really consider what I did here. All right. And then in a moment, what I'll do is I will move on to the next one. Okay, all right. So this is another one for me to do. I'm probably going to go through this one a little bit faster than the last one because I think hopefully I don't need to cover some of the same things. Again, if the last one was confusing, I encourage you to go back and look at them or use those timestamps as needed. Okay, so what I have here is I have negative. Notice the minus sign, the negative. Negative x minus 4 squared plus 9. Okay, so what I'm going to do is this. I'm going to now think about what's the easiest number to plug in. What's the number that would be really, really nice to plug in? The number that would be easiest, if I'm thinking about it, working smarter, not harder, is 4, right? Remember, with standard form, 0, C, easy. 0 is just not the easiest one here, right? 4 cancels this out, makes it 0. The negative, it stays 0. And then plus 9 gives me 9, right? So having 4, 9 on the grid is helpful. I just want to count, make sure. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes. Okay. What's another number that's easy to plug in? Think about it. What number would be really easy to get in here so that I could make this problem as easy as possible for myself? If you said a number like 5, that would be a good idea, right? Because think about it. 5 minus 4. Think about what it would look like. So sometimes you got to envision in your head. Think about what it would look like when I plug it in. Think about how easy that is to figure out, right? 5 minus 4. We know that's 1, okay? And 1 is really easy to square. So we square it, remembering PEMDAS. So you have to do exponents before multiplication, right? This is multiplying by -1. So it's 1 squared, which is 1. This makes it a -1. And then I add 9, and I get -8. Positive 8. So I have 5, 8. And then, which x has to have the same y as 5? It is 3, right? Because 3 is 1 away from 4, and 5 is 1 away from 4, right? Now, the 1, 3, 5 rule does work here as well. The main difference is that now we're going down instead of up. So if you recognize that, you could actually begin to get the points without really doing anything. I always recommend you plug in because that's the only way to be absolutely sure. So in the next one, I should be at down 1 over 3. I should be at 6, 5. Let's see if I'm right. So look, at this point, 6 and 2 are going to have the same output because 6 is 2 away from 4. 2 is 2 away from 4. So I could either plug in 6 or 4. Which one's easier? I would lean towards 6. So I'll just plug it in down here. 6 minus 4 gives me 2. 2 squared is 4. This makes it a -4. And -4 plus 9, go figure, is 5. And then 2 must have the same y value as 6, again due to symmetry. I think I need to go 1 up on both of these. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. Now, what I also know is, as it turns out, when I plug in 7 or 1, 7 minus 4 is 3. 3 squared is 9. This makes it a -9. So these actually turn out to be your y-intercepts. And then even if you want to apply the symmetry and the properties we've seen, I know that 0 is going to give me -9 because look, I'm going down by 1, down by 3. Oh, actually, I got to pull those up a couple. Right? Remember, we talked about how it's going down by 1, down by 3, down by 5, down by 7. Then it would be going down by 9, etc. Right? We talked about how the change of the change is always a constant number, and it's equal to twice whatever a is. So here, a is negative 1. So here, the change of the change is negative 2, right? 2 times negative 1 is negative 2, and that means we see that instead of it be going up, it's going to be going down. Okay, so, and notice, I always encourage you to plot as many points as you can. See how I get a really nice parabola? Like, you have to value the work that you do. Okay, you guys produce really, really high quality work, and you're capable of putting together something really great if you want to do it and you're willing to put in the time. I really need you to plot some points, and plot as many as you can, because the more points you can plot on the graph, the more beautiful your graph is going to look, and the more confident and the more like pride you're going to have in your work. Okay, so I hope this made sense to you. I really encourage you to go back and take a look at anything, but in a moment I'm going to move on to one that's going to be a little bit more collaborative. Okay, so now this is one for us to do. Okay, so this one I'm going to be a little bit more prompting, but I'm not going to have you full on pause. Okay, all right, so here's our function here. So in this case, again, we're in vertex form, and so I want to start by plugging in what number? I want to start by plugging in negative 3. And when I plug in negative 3, what happens? This becomes 0. This becomes 0 squared becomes 0. 2 times 0 becomes 0. And 0 minus 4 becomes negative 4. Now, if you know the symmetry here, you could probably know how to figure out the rest of the graph, and I encourage you to do that if that makes sense to you. Now I'm going to try to plug in what kind of numbers? Numbers that are near or far to the vertex. We want to stick by near. So in your head, think about two numbers. Knowing what the vertex, the x of the vertex is, think about two numbers that would be great to plug in right now. So I hope what we said was negative 4 or negative 2. Because when you plug in negative 4, you get negative 1. And when you plug in negative 2, you get positive 1. And negative 1 and positive 1, when you square them, are the same. And since the rest of the equation plays out, since the rest of the function plays out the same regardless, if we get negative 1 and 1 in the parentheses, the outputs have got to be the same. So I'm going to do negative 2. So I've got negative 2 plus 3 squared times 2 minus 4. So negative 2 plus 3 is 1. 1 squared is 1. 2 times 1 is 2, I believe. 2 minus 4 is negative 2. So negative 2 went in, negative 2 came out, negative 4 also must be negative 2. And notice again, if you plug in negative 4, you get negative 1 instead of positive 1. But when you square negative 1, it's the same as when you square 1. So therefore, the rest of it has got to be the same. So instead of starting by going up by 1, it started by going up by 2. Okay, now, what's the next two that are going to be the same? They are negative 1 and negative 5. Okay, so again, it's my choice. Do I plug in negative 1 or negative 5? I'm going to lead towards negative 1. When I plug in negative 1, I get negative 1 plus 3, which is 2. 2 squared is 4. 2 times 4 is 8. And 8 minus 4 is 4. So negative 1 went in, 4 came out. So therefore, when negative 5 goes in, well, negative 5 is going to make this a negative 2, which when I square it gets me 4, and the rest turns out just the same. Okay, so negative 1 goes to 4, negative 5 goes to 4. So here I'm going up by 2, 4, 6, right? So where's my vertex here? So I'm going up plus 2, plus 6, and as it turns out, when you plug in 0, well, this is 9, 18, you get 14, right? And so then when you're going to plug in negative 6, you're also going to get 14. So now it's going to go up by 10. So see, now it's going up by the change of the change, right, is 4. See how it's constant? And observe, observe, that 2 times 2 is 4, right? So the change of the change is giving us the 2a, okay? So last step is to connect. Don't forget to put your arrows on the ends. I'm very picky about the arrows on the ends, okay? I said that to people today, but those have been looking good. I appreciate that. Okay, so make sure you understood how I put this table together, okay, from start to finish. Pause if needed, but then in a moment I will move on to the next problem. Alrighty. So again, please make sure you understood what I did there. Now I'm going on to a very formidable problem. And that's mostly because of the a value. So two things. One, I've got a negative. Two, I've got a 1/2. So remember, one of the other things I said is when you start with these graphs, you got to start by asking yourself, what do I know? I don't, like, putting my pencil down. I'm not like literally my stylus pen is down. I'm not even thinking about the graph. I'm just looking at the negative 1/2 in parentheses x minus 2 squared plus 5, and I'm thinking, what do I know about this that was going to help me graph it? Okay, and what I know, right, is two things. One, is it going to point up or point down? It's going to point down. Why? Because the a value is negative. The a value, which is in front of the square, is negative 1/2. So therefore, it's going to point down. Now, what's my easiest point that I'm going to start by plugging in this form? It's going to be 2. And when I plug in 2, what comes out? 5. Right? And so remember, this is going to point down because, look, this is a negative. So now this is a variable number. It varies, right? Because this depends on x. If x is 2, it's 0. If x is 3, it's negative 1/2. You know, it depends on what it is. But it's being subtracted from 5. It's being taken away from 5. So therefore, the biggest number that we can get out of this comes from when we take the littlest possible number away from 5. And in this case, that's when we take away 0. Because we can't have any negatives coming out of the square. It's either got to be positive or 0. So among those numbers, making this equal to 0 is what is going to give us the least being subtracted, and therefore the biggest output, which is the vertex. Okay? So now I've got 2. What two super easy numbers am I going to plug in now that I've got 2, 5? And we should get in the habit of moving this to the middle. Okay, so the two numbers we're going to plug in are 1 and 3. What's the next two numbers I'm going to plug in? That would be 0 and 4. If you know the symmetry, feel free to do it, though it might not be easy. I bet you the number negative 1 will be useful too. So now I'm going to plug in 3. 3 minus 2 is 1. 1 squared is 1. Negative 1/2 times 1 is negative 1/2. Negative 1/2 plus 5 is 4 and a half. Okay, and 1's got to be the same thing. Okay, now I got the choice between 0 and 4, so I'll do 4. 4 minus 2 is 2. 2 squared is 4. 4 times negative 1/2 is negative 2. Negative 2 plus 5 is 3. Okay, observe how, let's take a look. So it's going down by 1/2. down by 3/2 or 1/2. See what happens if I plug in 5. This will give me 3, 9 when you square 3, negative 4.5 because it's negative a half times 9, and that would be 1/2. So see how it's going down by 5/2. So it's going down, notice. So the first time you just knock off the A, and now it's going down by 2 of A, right? So it's going down by 2/2. It's going down, the change rather is going down by 1, right? So now instead of going down by half, it's going down by 1.5. Then the change goes up by another 1. So instead of going down by 1.5, it goes down by 2.5. So if you can understand the symmetry, and it's not easy, okay? I'm not expecting you to look at this and understand the symmetry right away. Symmetry is a very non-obvious phenomenon in math and property in math that is not, that's been studied for a while, and that makes math one of the, pretty beautiful, and highlights those really cool things that I like about math. But it's not easy always to understand, okay? But if you can work with me and put in that time, you can be successful there. All right, so please make sure you understand what I did here in terms of the graphing, making sure you should have a facing down parabola. Noticing this is a little bit more stretched out. This one's a little bit more narrow, right? This one's kind of like in between. So narrower, in between, a little bit wider. Okay. Please make sure you understood what I did here. And then in a moment, I will move on to the ones for you to try. Okay, so there's going to be 2 U tries. Here's the first one. So in this, what I want you to do is this. I want you to take a look at this function. If need be, maybe go back if you don't know where to start, and maybe look back at some of what I've done in the past few pages here, and going on probably 30 plus minutes of explanation. So, and take a look at that, and then I want you to try to graph this. Think about the strategies, think about the methods, think about what's going to come out of this, and I want you to pause the video, do your best to make a graph and a table. The graph containing the vertex and 4 other points around it, okay? And then when you're ready, unpause, and I'll show you how to make the graph. All right, so remember, the first number we're going to plug in is what? We're going to plug in, since this is vertex form, -3. And we plug in -3, what should come out? What should come out is 7, because this will be 0 plus 7, okay? And remember, you kind of do want to make your vertex in the middle. Now I'm going to do the non-vertex points in a different color. Okay? So I've got -3. Now, based on this graph, this formula rather, should this graph point up or should it point down? It's going to point down based on the negative. Okay? So now what I'm going to do is I'm going to plug in 2 numbers around it. What are the 2 numbers that would be good? Ooh, and I don't want +3, 7. I want -3, 7. That makes a big difference. Okay, so there we go. All right, so I need to plug in 2 numbers around -3. What should I choose? Well, 2 good ones would be -2 and -4. Those are both 1 away from -3, right? I go up by 1, I go down by 1. So therefore, their y's must be the same. So I plug in -2 plus 3, I get 1. So I get this. 1 squared is 1. Making it negative makes it -1. And 1 plus 7 is 6. Okay, and then I will get the same thing if I plug in -4. What can I plug in next? What would be the next best couple to plug in? That would be -1 and -5. Okay, -1 plus 3 is -2. -2 squared is 4. This makes it a -4. And -4 plus 7 is 3. And those, again, must be the same because of the symmetry. Okay, if we were to keep going, right, we could do 0 and -6. Well, we could use the pattern. We know it's going down by 1, down by 3. So we should get -2. It goes down by 5. Let's see what happens. So what we'll get is 0 plus 3. That's 3. 3 squared is 9. -9 plus 7. It's going to be -2. Okay? So notice how the more points you can plug in, the better. Okay? It really makes, to me, a big difference. Okay? And then, actually, it's going to go down by 7 after that. So you really get a full parabola. And see how much it makes a difference? Even for someone who, I'm on a tablet here, and I'm having to, like, draw this in. And, you know, this is not a high accuracy tablet. So see what a difference it makes, though, to have more points? It makes my graph something I can be a little bit more proud of. All right? All right. So again, hopefully you got this right. If not, please go back and understand how I did this. I do want to point out before I move on that some people ask, look, Mr. Murray, why don't I just plug in 0, 1, 2, 3, 4, 5? This is a perfect example of why you don't do that. Because look, 0 gives me -2. 1, well, we don't know. I guess we do know it gives me apparently 9. Apparently 1, because we're supposed to go down by another 7, right? Down by 1, down by 3, down by 5, down by 7. So supposedly we get -9. And it would be -16 plus 7. In any case, essentially what we want to think about is, I kind of lost my train of thought. Wow, sorry about that, folks. So in any case, think about what we got going on here, right? Think about the symmetry. Make sure you understand really where everything's coming from, right? Okay, so this is what I was thinking about. I apologize. So notice that by the time we get to 1, we're at -9. So 2, 3, 4, these are going to be way off the graph. So don't indiscriminately plug in numbers. Try to make it, to take a second and think about what these have in common. And think about, like, the vertex and that's got to get on the graph. So why don't I start with the vertex? Start with the points that you can get easily, and if you can find these patterns, it will be helpful. In this case, we did get lucky. If we had gone -1, -2, -3, -4, -5, -6, we could have gotten there. But think about how you can save yourself time here by starting with the vertex and thinking about how you use the symmetry. Those are really big takeaways for this unit, okay? So if you need to, please go ahead and review anything, and then in a moment I will move on to the next problem. All right, this is going to be the final problem, and this is just a little bit more tricky of a parabola. So I'm going to ask you to, again, go ahead and take a look and try to make a table and a graph of this. So we'll pause the video, attempt that, and then when you're ready, unpause, and I'll show you how we'll solve the problem. All right, so here's how we're going to solve it. Remember, what are we going to start with for our x? We're going to start with -5. -5 makes this 0. 0 squared is 0. -2 times 0 is 0. And that gives me 1, 2, 3, 4, 5, 2. Okay, perfect. Now, again, thinking that this is probably going to be in the middle, where am I going to go next? What do I plug in next? Maybe plug in -4 and -6. -4, when I add 5, I get 1, so I get something like this. -2 times 1 squared plus 2. So 1 squared is 1. -2 times 1 is -2. -2 plus 2 is 0. Okay? And so therefore, 6, because of the symmetry, has to be exactly the same. Now I'm going to plug in -7 and -3. -7 plus 5 is -2. So I have -2. I have this. -2 squared is 4. -2 times 4 is 8. -8. -8 plus 2 is -6. That connects. That connects. Okay. One of the last things I'm going to show you here is how do we do it with a calculator. So, and this works for, I believe, any of the TI 84 plus, and I believe if you have a Casio, there is a way to create a table. I would encourage you to reach out and kind of figure that out, because there is a way that you can do that. Okay, I'm not exactly sure how, but if need be, if you're willing to stay with me and work with me after school, I'd be happy to show you how to do that if we can figure it out. Okay, so here what I'm going to do is, now that I'm in this view, I'm going to go ahead and I'm going to make this look exactly like my function. Remembering the X button is next to alpha. Okay, it's right here. I'm circling it with my pen, right next to alpha. It's now red. Okay? To get the squared, you can either click this button, the squared button, or you can click the caret button followed by the exponent. So the caret gives you any exponent you want, and the reason they have squared is because squared is just a common choice. So it's like a shortcut almost. So if we take a look, I wonder if I can, no, I can't zoom in. So take a look and observe that this is the same as our function here. And so what I can do is I can hit seconds, and then I can hit graph, and notice how what that does is it pulls up a table. And I just need to really quickly change my table settings. So my independent is on auto. And notice now when I make my table, if I do seconds, up, seconds, table, oh, there's my graph. Nice, looks very much like mine. But if I do second graph, it takes me to a table that generates a whole bunch of values for me, right? So that's an option you can use if you have access to a calculator, though you might not always have that. So just be aware that I am putting a high emphasis on you being able to do this without a calculator. Okay, so I hope you found this video to be informational. I hope that you gained a little bit more insight into how to graph quadratics. Again, think about the patterns that we're working at. Think about some of the similarities between the forms and some of the differences. What's ideal about vertex form, right? The vertex is easy to find. What's not so good? Well, the y-intercept, as you can see from this graphing calculator view right here, is -40. That's not easy to find. And not only that, we got to plug in 0, we got to square 5 to -2. So very difficult to find, okay? So they all have their pluses and minuses, all right? So keep thinking, keep your mind open, keep exploring what we're doing, because the quadratics are so beautiful, but they're only going to be as great as you allow them to be, okay? So I appreciate you watching the video. Don't forget to send me questions anytime. Come before, after school, or during advisory. And remember, you can do it. All right, stay positive. Don't forget to love math, and have a wonderful day.